Edinburgh in Scotland, and I work as part of a translational research centre called the Patrick Wild Centre, where we have a particular focus on, as you just heard, single gene conditions associated with intellectual disability and with autism. I'm going to talk one of the genes and one of the conditions that we're obviously very interested in and have been for quite some time is in SYNGAP1, and I'm going to talk today about some of the work that we've done looking at, as I say, behavior and cognition in SYNGAP1. These are the things that are, I guess, most not interesting to me, but you know, as a psychiatrist, these are the things that, you know, I feel that I can probably contribute most, or at least talk about most in this condition. There's obviously other physical manifestations and so forth, which I often feel slightly less qualified to discuss. So I've moved my slide on. Hopefully that has moved on. Please do tell me if it hasn't. What I'm going to present is data today from this big, almost completed study that we've been doing called NeuroGD, basically studying neurocognitive presentations of monogenic conditions, of which, as I say, SYNGAP1 is one of the main ones. We started it just pre-pandemic, and therefore that meant that it took a lot longer to complete than we had hoped. We have now finished our data collection for this study, and we're kind of going through some of the analysis. So what I'm going to do is present some of the data from these areas today. So from the clinical interview, from some of the standardized questionnaires, where we were really looking at behavior and emotional difficulties, and then some of the cognitive data that we have analyzed so far. So the semi-structured clinical interview, I mean, really what this was just us asking families, what were the things, usually the difficulties, because I'm a doctor and that's what we tend to talk about, but what are the kind of difficulties, particularly behavioral traits, I suppose, and difficulties that they see in their children? Because really when we started this, and I think even now, not huge amounts have been done about the behavioral kind of phenotypes, and so we just thought one of the best places to start was basically to ask families what they saw and tell us what they saw. This study had 27 people with SYNGAP1 in it, mainly around about the age of 8 as a mean, mostly recruited through parent support organizations like SYNGAP1 Foundation, and mostly diagnosed through research studies. So, you know, not people, there were a few who'd been picked up through clinical testing, but the vast majority had come through research studies, particularly two big ones in the UK. One, the Deciphering Developmental Disorders study, which was a large exome sequencing study that went on here, and the 100,000 genome study as well. So just to give you a bit of a flavor, you know, of you know, the population that we had, about half had a diagnosis of autism, so a clinical diagnosis. Only 7% had a clinical diagnosis of ADHD. Now, that doesn't mean that people didn't have ADHD or autism, it just meant that it hadn't been diagnosed. This is the reported diagnoses that the parents have been given. And then about 70% had epilepsy, of which the main seizure type were absent seizures. And to give you some idea, you know, of where people were at, or, you know, about 70% of just over 70% of the children that we saw were either non-verbal or using only single words. Most of them were walking, at least to a certain degree, and just over half, were able to pick things up with the kind of standard sort of picture. So even from that, I mean, I think it sounds like a fairly representative group of people. And this is what people told us. This is work that we published last year. I don't think there was anything desperately surprising in this, to be honest. You know, I mean, what people talked about were difficulties with things like emotional regulation, getting frustrated and becoming distressed, and that can then lead to aggression or self-injury. We heard about difficulties coping with change and novelty. So these sort of stereotype kind of behaviors, or getting very focused on certain things. And then sensory differences as well. You know, both sensory likes and sensory dislikes. And then other things which I think are associated with day-to-day living. So, you know, day-to-day living skills, being able to eat, feed yourself, toileting, being able to, you know, the people's awareness of danger or lack of awareness of danger. So these are the kind of difficulties that people talked about, are the kind of differences in behavior that parents noticed in their children. So what we then wanted to do was to go on to look at this using more kind of standardized questionnaires of behavior. And we did an awful lot of these. Anyone who participated in the study, I do thank you, because there was really quite a lot of questionnaires that we did ask people to complete. I'll talk a bit first of all about how we measured adaptive behavior and what that is, and then sort of maladaptive behavior or behavioral difficulties. We had a few more people. This overlapped very much with the published study, the parental interviews, not entirely, but it was a similar kind of group, around about 8 years old. Again, about 40% of this group had an autism diagnosis, very few with an ADHD diagnosis, but 2/3 had a diagnosis of epilepsy. And apologies for, there's going to be quite a few graphs coming up at times in this measure, but in this talk. But we started off, we looked at adaptive behavior using a measure called the Vineland-3, which is a very widely used measure of these kind of behaviors. And these are really the sorts of behaviors that people need to manage in day-to-day life. It measures across a few different domains: communication, daily living skills, and socialization. And then hopefully you can see on the graph where the black arrow is, it provides what's called an adaptive behavior composite. So it kind of takes into account those 3 domains and then provides a kind of overall composite score. It's standardized a bit like IQ, and it's standardized for age. So what I mean by that is that, you know, for someone to get a score of 70 at 3 years old, they need to be able to do, or at 10 years old, they need to be able to do a lot more than somebody who's 3 years old. Kind of normed for age. And then it's also normed, as I say, a bit like IQ. So if you take the general population, the mean is about 100. And you can see that from the blue bars at the top of this are controls. And throughout the whole talk, blue will generally be controls and red will be SYNGAP1. And they score mainly around about 100 on these different domains. Anything below 70 is considered 2 standard deviations below the mean. And that would be kind of very significant clinical impairment. And what we see is, perhaps unsurprisingly, that in our whole population, children with SYNGAP1, there's the vast majority have got an adaptive behavior composite score of below 70. We also see that it correlates very well with nonverbal IQ, which I'll touch on later on. We measured it using a thing called the Likert-3. But, you know, really very clearly from the graph on the right there, higher nonverbal IQ means that people are more able and, you know, have a higher adaptive behavior score. The other thing I think that we noted on this, or one of the other things we noted in this, is that, you know, and this is again unsurprising given what we know and what we see and the people who see in clinic and so forth, is that communication is particularly impaired. You know, you see that this is an area where people have more difficulties than maybe in some of the other domains, and motor skills are relatively less impaired. Although, you know, it's really important to note that people have difficulty across the board here. These are all just relative differences. We then looked at relationships with age. This caution warning sign here is really important. This is cross-sectional data. So this is not longitudinal data. We didn't follow people up in this study. This is just looking at, you know, are the older children in our study do they have greater difficulty than the younger children on these measures? And they do. And interestingly, that's particularly driven by those who have epilepsy. There isn't a relationship. It's not just not significant. The R value is fairly close to 0 for the ones who don't have epilepsy. So we find that, you know, in this population, particularly those who have a diagnosis of epilepsy, the older children were more affected or had lower adaptive behavior composite scores than the younger children. But like I say, this is it's easy to interpret this as, there is this decline over time, but the way that the population has been recruited could mean that, for example, our older children, if we'd seen them when they were younger, they maybe would have had a quite low adaptive behavior score as well. So it could be an artifact of the recruitment of the population as opposed to representing true failure to keep up with the typically developing children. And that is the other thing that's important, is that it's not a decline. This isn't necessarily evidence of a regression as such, that people are losing skills that they already had. Again, this is cross-sectional data, but when we look at the raw scores, so we look at the scores that aren't normalized for age, you do tend to see that the older children are a bit more able than the younger children. But certainly, or at least that they are not less able, what you don't see is a clear kind of deterioration. So it suggests really that people are, not managing to develop new skills, which is perhaps unsurprising in a developmental condition, as opposed to that they are losing necessarily skills they've already acquired. Again, though, cross-sectional data, so lots of caveats associated with that. Moving on to think about emotional and behavioral difficulties. These skills we used here are part of the Achenbach system. I don't know if people are familiar with it, but it's really quite detailed measures of various different behaviors that can cause difficulty for children. It's been widely used for a long time. They're really good skills. I'll take a long time to actually complete for people. One of the things that is difficult about them, though, is that they are slightly different for different ages. So thinking about looking longitudinally in the future, these maybe weren't necessarily the best choice, because you actually change scale from below 5, 2 to 5-year-olds use a scale called the infant behavior checklist, and then 6 to 16 use the child behavior checklist, and then above that use the adult behavior checklist. So they're a bit difficult to kind of compare changes over time of people with these age groups. What they do give you, though, is quite a nice overall look at different behaviors and difficulties that people have. They divide, the total score, which is on the right, again, SYNGAP are in the red and controls are in the blue. Total scores above 60 and particularly above 65 suggest kind of clinically significant difficulties. And we see that our mean here sits on that line. You'll notice that none of the controls here hit that line. So even these difficulties below could be clinically significant if they were in particularly troubling kind of behaviors. But you see, again, the SYNGAP group are impaired, particularly no massive pattern that externalizing behaviors, so things like aggression and agitation, irritability, are much more difficult, or much more prominent, than internalizing behaviors on the left here, those are things like withdrawal or mood difficulties. They're both equally as prominent. Generally, people find externalizing behaviors more difficult to cope with, because by their nature they affect other people more so than the internal ones do. But they're both fairly common, and when we look at the combined score on the right-hand side, you see that there is lots of difficulties again across the board in these measures. You can break it down into a bit more detail. You start to lose data because these don't translate between the infant behavior checklist and child behavior checklist. But we see particularly high scores in things like attention problems and in social problems. I would say, these sort of withdrawn and aggressive behavior and thought problems are also relatively high here, but it is the sort of social and attention problems that really do stand out. All of them are higher than the controls, though, I should say. So all of these kind of emotional difficulties, behavior difficulties, the children with SYNGAP1 score higher on than controls, but particularly high rates of attention difficulties and social problems. Which is interesting, because I think I said at the beginning, although about 40 to 50% of this population have a diagnosis of autism, a lot don't. and certainly many don't have formal diagnoses of ADHD, whereas we do see really very high levels of attention difficulties. I mean, that's attention difficulties themselves are not diagnostic for ADHD by any means, but this could represent something which is particular to the UK, in that we often tend not to, in my view, we underdiagnose ADHD in people who've got quite marked intellectual disabilities. So, you know, and I think there's something important about being able to recognize when these things are part of a broader ADHD condition, when there are quite effective treatments out there that can be given to help. The other thing we looked at, again, caveat, cross-sectional data. But the other thing that we looked at was how these may potentially change with age. And a bit like we find with our Vineland scores, you see an increase. You tend to see that older children are more affected, and tend to, it's not significant for all of these measures, but they tend to show more difficulties than the younger children. Looking in a bit more detail then at autism and at ADHD, we used a measure called the social responsiveness scale for autism. It's a very good, widely used scale. It may be, we think actually that in people who've got quite marked intellectual disabilities, it possibly, some of the features that the social responsiveness scale picks up and describes as autistic, you know, that are attributed to autism could in themselves be related to IQ differences rather than necessarily autism. But certainly people score high on the scale. Over 65 puts people into the moderate into severe impairment range, and the vast majority of our group scored over 65 in this scale, suggesting that regardless of the cause, they've got pretty marked impairment in social communication difficulties and repetitive behaviors. Interestingly, and a bit related to what I mentioned there about IQ, you know, there is a negative relationship with IQ. So people of higher IQ score less on this scale, which does suggest that at least some of these traits are maybe driven more by IQ than necessarily by autism per se. But these are very difficult things to actually try and parse out. But also interestingly, no relationship with age for the SRS within the SYNGAP group. So, you know, although they appear to be more effective in terms of, you know, their when we look at adaptive behavior and some of the emotional difficulties and things, we don't see that our older population are more autistic. If we look at ADHD in more detail, here we use the Conners scales. Again, you know, there are measurement difficulties in these in populations with, you know, non-verbal populations with quite marked intellectual difficulties, and the Conners scales were not validated on these populations. They were validated in the more traditional child and adolescent population. But however, you know, they do clearly show high levels of impairment in our SYNGAP1 group. And interestingly, they don't show any relationship with IQ. You know, and that to me makes it feel like they are potentially tapping this inattention, hyperactivity is something that's maybe not just driven by factors SYNGAP1 group have got, you know, a lower IQ or intellectual disability, that they are maybe a dissociable and separate kind of, or partially dissociable and separate kind of thing, which means, you know, that again to me, and I would be quite tentative about saying this is and I don't quite know what the practice is in the US, but we need to be more aware of the possibility of ADHD as a potential diagnosis. So I've just had a message saying my internet connection is unstable, so hopefully you can still hear me. I imagine it relates to these 3 boys currently playing online games in my house at the same time as I'm doing this. So if there's a problem, do let me know. So what do we find when we think about these kind of adaptive, maladaptive, autistic kind of behaviors and ADHD traits? Overall, you know, unsurprisingly, adaptive behavior is lower, and emotional and behavioral difficulties are higher. And we see a few patterns of things like communication being areas of particular difficulty, as well as attention and social difficulties. As I say, high levels of autistic and ADHD traits, although the autistic traits might be IQ related, and the levels of ADHD traits far outweigh the number of people who are receiving a formal diagnosis of ADHD in this sample. And certainly I should say that, I've not talked about it here, I think one child in this sample was treated with anti-ADHD medicines. So it's not like people were being treated in the absence of a diagnosis here. They were not being treated for these difficulties. And then this hint that older adolescents are potentially more affected than younger. And that might be the case more so for those with epilepsy than those without. But again, lots of caveats around that kind of cross-sectional assumptions that we make. I'll touch briefly on sleep. I know that you've heard from both Connie and Jimmy here earlier today, I think. Hopefully at least one or other of them presented this, as they were really the people who were leading on this study. We just submitted some of our data that we've collected using the same scale to contribute to this study that was published a couple of years ago, but which really confirmed that very quite marked sleep difficulties in children with SYNGAP1, and possibly even more marked than in this other genetic syndrome, Phelan-McDermott syndrome, that was also looked at here. I have two colleagues here who have been looking at sleep in more detail in this EVOSIS study. It's Lindsay Mizzen on the top right there has been leading this, along with Stevie Williams, who's the sleep technician who works on it. And they've been going out and going to people's homes around the UK and doing polysomnography on children with SYNGAP1. So that's at the bottom right. You can see children hooked up to all of these sort of probes and things that they then go to sleep with. And they've also been doing actigraphy as well. So using these watches that children wear for a week to try and actually quantify sleep and activity over that time. So they've been out to see 13 children with SYNGAP, along with 14 controls, who are generally the siblings who get volunteered into the studies as well. And they've been comparing them these measures. They're currently analysing these data, particularly the polysomnography data. Lindsay sent me a little bit of the actigraphy data that they have done to date, which confirms, really confirms the clinical findings from the Childhood Sleep Habits Questionnaire that I mentioned before. Actigraphy was able to quantify in this relatively small group differences in efficiency of sleep. So that's how much time the child spends asleep compared to how much time they are in bed, which is lower in the kids with SYNGAP1. And then the proportion of children who wake after their sleep onset. So, both of these measures were more showed greater impairment in the children with SYNGAP1. And I think it's interesting, particularly if we think about future and trials and potentially using objective measures to try and quantify some of the difficulties that people have. Actigraphy is potentially one such area. Lindsay's going on to try and expand this, and then they also want to look at the, as I say, the polysomnography data as well to see what other things that they can learn. So I'm hoping I'm doing okay for time. I'm going to talk briefly about the nonverbal IQ measured by the lighter 3. I don't know if people are familiar with the lighter 3, but it's a totally nonverbal test. So it doesn't rely on speech to actually administer it. It also then means that it only taps nonverbal IQ. So it's not measuring verbal abilities. And probably just the thing, we still need to look at this in more detail. Not all of our children were able to do it, not because they weren't able to have their IQ assessed, but just because we weren't able to get everyone, because of the pandemic, to come up to Edinburgh or to see people at home to do this. So we have 20 children with SYNGAP1. This is the graph earlier on, which I showed you just of nonverbal IQ versus adaptive behavior. So nonverbal IQ is on the bottom. Probably the most interesting thing to me here is that if you look at the adaptive behavior, think I said earlier on, the vast majority of people with SYNGAP1 score below 70 on adaptive behavior. So really 3 people scoring just above. And that's not quite the case for nonverbal IQ. So this line here is roughly at 70. So that's classically where we would give someone a diagnosis of an intellectual disability. And if we only look at nonverbal IQ, there's actually about 40% of our participants had an IQ of above 70. And I was quite surprised at this, to be honest. I expected most people to score below 70. You know, particularly if you consider about 70+% of this population have effectively non-verbal or only use single words. If you did a full scale IQ, so looking at verbal and non-verbal together, the chances are most people would score less than 70 overall. But if you just look at someone's non-verbal abilities, actually, as I say, there's a reasonable proportion who do reasonably or relatively well. And I think it's just important to bear in mind that people are probably more able, and I think families will say this, that their children are often more able than they are given credit for, because when somebody's not able to speak much, there's a tendency to think that they're maybe more cognitively impaired than me. So I'm not saying, you'll notice that nobody here had an IQ, none of our SYNGAP group had an IQ of 100, which would be the population mean. So people are still scoring below the mean, but I think probably less impaired in non-verbal IQ than they are in verbal IQ, if we've measured that, and less impaired in non-verbal IQ than in adaptive behavior. Now, the LIDAR does divide into a few different subscales, which we still need to look at, although an initial look at them didn't really show any particularly pattern of strengths or difficulties. It was a kind of relatively, in terms of non-verbal IQ, the different tests, people tended to score quite flat across them. So it wasn't that there was sort of peaks of ability and troughs of difficulty that people have. But we need to look at this in more detail still. Lastly, I'll talk a little bit about the eye tracking that we did. We did 3 different tasks of eye tracking. I'm only going to talk about the social attention one here, mainly because we haven't finished analyzing the others. For those who, most people may know what eye tracking is, but basically, the child, this is Aisling, the research assistant on the right-hand side, with one of the children with SYNGAP1, going through some of the eye tracking tests. And basically, what you're asking people to do is to look at a screen, and you measure where someone is looking, how their eyes move, and you can also measure the size of their pupil. And you can use that then to look at cognition in a way that doesn't necessarily require the child to actively engage in. So, while the thing you can see there with the X's and O's is not that engaging, there are other things that come up on the screen to try and actively grab the child's attention, maintain them focusing on the screen. The nice thing about eye tracking, though, is it is passive. So you're not asking people, you don't have to explain much in terms of instruction. People just watching the screen. And therefore, it's quite good for doing non-verbal, cognitively impaired people, very young children. Like even little babies, you can do eye tracking with. It's not asking them to actually take part in this. And it does have a potential for use in clinical trials as an objective outcome. So what we wanted to do was look at these different cognitive domains, check the feasibility of it. Could children, could our SYNGAP1 population actually do these tests? And then if they could, be able to look at, what did they actually tap any? So here's the 3 social tasks that we did. I think we went slightly overboard on the social tasks, to be honest. I don't know that we necessarily needed to do 3, but it was useful to see which one I think is probably the most, tells us the most about our population. We did a simple, these are not new tasks. These have been well used in other studies before, but face processing, showing people pictures of faces and seeing where they look. And most typically developing people will have a bias towards the eyes and the mouth, and to an extent the nose, these feature areas of the face, but particularly the eyes. We then did what's called a pop-out task, where we have a face, which is the social stimulus that kind of sort of messed up or noisy face where you've got the same sort of shape but no necessarily social cues on that shape, and then a few other random things, including a very out-of-date mobile phone. But you know, a bird and a car and a phone. So these are just objects. One is a living object, two are you know, obviously inanimate objects that may have varying degrees of interest for people. But you're looking there in that one to see, you know, which do children look at more. Then in the last one, we have social scenes and non-social scenes, but basically scenes where you have a child or a face or a person in them versus ones where there are just objects. And again, you're looking at how much time you spend looking at which of these. And the idea of all of these is to tap into social processing, really, the kind of natural bias that most typically developing people have towards social stimuli. Feasibility was interesting. We had 25 people took part in this part of the study. So 25 people came and did the actual eye tracking. Only 7 yielded what we would traditionally define as high quality data. The vast majority of difficulties were about someone's ability to calibrate to the eye tracker. So really at the beginning of the eye tracking, what you're doing is you put up these, you flash up on the screen, kind of interesting little cartoons that appear on the screen. And that naturally draws a child's attention to it. And we put a relatively strict threshold on of, you know, if you are more than 2 degrees out from that, you know, so if you're looking just to the side of it or you're not looking at it at all, but even 2 degrees to the side of it meant that you would be excluded. And what we found, there was only 7 of our 25 people met this criteria. So that's what I'll give you the data from. We have gone back and said, well, what if we just take everybody, you know, what if we get rid of lower our, you know, quality criteria as such, and see is how realistic is it? Do we see similar findings? And actually we do. You know, we're just literally these data are just, you know, being analyzed at the moment. But we think we may end up including more people than our kind of initial. We'll report both probably, but I think we will be able potentially to include people who maybe showed even greater degrees of deviation and had struggled more with the calibration side of things. But we need to look at that in more detail. But so the data I'm presenting here, though, are really just on small number of children who were able to do this task and do it well. And perhaps unsurprisingly, they were the children who had a higher nonverbal IQ, you know, with the mean here of 67.7. So they're probably the ones who are shifted to the right-hand side of that graph earlier on. And 4 of them were autistic. And we measured autistic traits in this study, again, using the social responsiveness scale, which I talked about before. And so what did we find? Even in this small portion group of people, we got the results we kind of expected, particularly for the face processing. So as I said to you earlier, so in these graphs, the red are SYNGAP and the bluey green are controls. The most people have a natural bias, for want of a better term, towards the eyes when you look at a face. That's where you're drawn to first, and that's where you look at most. And in both these measures, which are proportional looking time, so that's the amount of time someone looks at, say, the eyes compared to the rest of the face, or the fixation count, the number of time people look at the eyes, you see that typical bias in our blue group. You see they look at the eyes more than the nose or the mouth. What you don't see is that bias in our SYNGAP1 group. So they look less at the eyes and at the nose and at the mouth, and they look equally at the eyes, nose, whereas our typically developing controls look more at the eyes than the SYNGAP1 group do, and they look more at the eyes than they do the nose and the mouth. What you do see then is that the children with SYNGAP are looking more at other parts of the face and other parts of the picture. So they're not showing this bias towards any of these more social regions or feature regions. They're looking at these more non-feature face regions. And interestingly, we find that tendency to focus on non-feature regions was highest in our most autistic participants. Now, there are small numbers here, so it would need to be replicated with higher numbers, and we'll need to see if this holds true if we do lower our quality control standards, I suppose, for the IQ. But it does suggest that this is picking up what we expected to pick up, that those people who are clinically more autistic are ones who tend to show this typical autism-like or previously reported for autism sort of lack of bias towards the eye region and potentially aversion from the eye region. We also find that even when we zoom out a bit and we just have this pop-out task, as it's called, you know, our typically developing controls look more at the face than they do at other the other stimuli that we show. And again, we don't see that in our SYNGAP1 group. So they don't show this bias towards the face, and they look at it at the same amount roughly and for the same amount of time as they do these other non-social kind of features or non-social stimuli. Interestingly, and you know, this in contrast, I think, to some of the other two tasks potentially, we didn't find that bias away from social information in when we just took these even more zoomed out social versus non-social scenes. So, you know, both, if you look on the left-hand side, both the red and the blue, SYNGAP and the developing show a bias towards social as compared to the non-social. Both of them look more at the social side of the social. You know, it could be in part that there is more interesting things and more stuff going on in general on the social side of things. But it does suggest that, you know, there is, at least at some level, there is a degree of bias towards information. But perhaps maybe it's not biased so much towards faces as it is in, you know, in typical individuals. But maybe there is this social interest, but maybe it's not shown in the way. It's a difference in a processing of emotion and processing of features and facial features than necessarily it is in terms of social interest and motivation. And I should say, so that, I mean, that does fit slightly. Lots of parents have told us, and we see it a little bit when we look at some of the subscales of the social responsiveness scale, that social motivation is an area of relative sparing within our SYNGAP population. But we need this again. We will look at in more detail as we move forward. Hopefully, publish it later on this. So overall, for cognition, I probably one of the most striking things to me was the range of values of the people scoring their non-verbal IQ, and higher than expected, particularly when we consider verbal abilities. The eye tracking was interesting and clearly, to me, does show objective evidence of differences in social processing. And if I had to choose one task that I wanted to do again in the future, it would be using that face processing task, which I think gave us the most information and was related to the clinically measured autism traits. I do have some concerns about its longer feasibility in terms of moving into clinical trials and things, but as I say, certainly our experience was that calibration was quite difficult to do for some. Which may limit its usefulness going forward. I certainly wouldn't rule it out, and there's bound to be more things that we could do to up the quality and make things a bit more visually engaging for people. But it is one of the things I think needs considered carefully, kind of moving forwards. What are we going to do? We need to finish analyzing these data. It has taken far longer to get the data than we had hoped, but we are now beginning to churn our way through it and hoping to get there are 2 papers submitted in the behavioral data. The first eye tracking data will hopefully go in fairly soon as well, and then we'll move on to the other eye tracking domains and the EEG data. I think one of the most important things that we need to do is look at longitudinal data to try and examine clinical course. We are going to do a follow-up study of this population, repeating some of these behavioral measures. The person on the right is Sydney Weisgold, who is a Ph.D. student who has just started with us, who her Ph.D. is part funded by SYNGAP1 UK. And the idea behind that was to look at the longitudinal aspect of behavior, to focus particularly on the kind of difficulties that cause people distress, some of these externalizing behaviors, the aggression and the self-harm and things. And then she is also, but we're going to repeat some of the other measures as well. And then she's also going to look at some other physiological measures that might be associated with behavior, things like heart rate variability and so forth, to see, you know, are there things that we can capture? You know, does people's behavior really change over time? Does it get worse, or does it stay the same, or does it get better? And can we predict who might be more likely to show those difficulties using some of the, to say, these physiological measures? So that's her PhD, which she is, you know, 2 months into at the present time, but I'm hoping that we're going to generate some quite interesting and useful data moving forward. And just to finish off, to thank the people who were who actually took part in the research. That was the picture there was from the first UK family meetup, which was just pre-pandemic. There was a second UK family meetup, which I got COVID for, so couldn't actually attend post-pandemic. And then we're hoping to have another one in October of this year, you know, and thanks very much to the SYNGAP1 Foundation, and you know, we have a lot to do with Monica and the foundation as a whole for a long time, and to SYNGAP1 UK as well, and also the SRF, all of whom helped contribute very much to recruiting for this study. And then the people in the bottom right, Damien and Aisling, these are the people who did pretty much all of the actual work in NeuroGD, and then Lindsay and Stevie who are doing the Vosis work. So, thank you very much.
Thank you very much.